Welcome to an overview of SAATS, Software Automated Analysis Toolset for Maintenance. We start this three-part video with our challenge, which is the many questions created by aircraft maintenance, parts problems, changing missions, aging aircraft, and more. Data in many different systems, formats, and access protocols, and a diverse user community with engineers, logisticians, maintainers, and operations specialists. With all the reports and dashboards out there, how often can you find exactly what you need? Does answering maintenance questions feel like a hunt? How many analytics boxes do you have to open until you find what you need? How often are you recreating similar queries over and over? SAAT's approach is to clear away that burden and make it easier to find and reuse what you already have. Analytics is no different than building jet engines. There are standard ways of doing things, sequences to be followed. What we need is a workflow for analytics, a place where we have tools, see data, and configure exactly what we need. We'll demonstrate such a workflow. We'll show how workflows simplify creating queries, reusing queries, sharing queries among users, and even launching a query using natural language. Microservices, or agents as we call them, are the tools we use to build standard workflows. These agents are small units of purpose-built code from which we build standard workflows. You spend less time coding, searching for data, more time with the results. Agents can be tasked to work separately or together. Generally, there are four kinds of agents. Search. They find required data. Which database has what you need? Fetch. They capture required rows and columns of data. Analyze. They aggregate and prepare data. These agents either answer your question directly or prepare data for later drill down. And finally, output. In the format you need, tables, reports, visualizations, and more. Software containers are a second key architecture principle. You can think of containers as drawers for storing intelligent agents. Drawers make it easy to maintain code according to different purposes. Drawers make it easy to catalog and search for tools you need. If new analytics are needed, it is easy to simply add a new drawer. Let's face it, maintenance analysis can be challenging. When data is hard to find, a workaround is to use what you have and make assumptions on the rest. That can make the job longer, because making assumptions well and consistently is difficult. The data is available. Getting it should be easy, and SAATS is here to make that happen. And next we will demo what we have started, which is a small but powerful workflow to showcase our agents and containers approach. SAATS is web-based analytics software for any tablet, smartphone, or desktop, just by typing a URL. Our use case for the demo today is situational awareness, a fundamental question. What is happening with my assets? Users usually have a specific angle they need, by fleet type, squadron, by part number, basic views of maintenance captured from MAFs or maintenance action forms. When we know these angles of inquiry in advance, we can build a simple workflow for different user interests. Our demo will show a drill down sequence that starts with aircraft type with three options for analysis: by organization, malfunction code, by part removals, and then two further levels of drill down. And even though this workflow is limited, once queries can be shared and reused, it becomes a building block for more complex analysis. On the home screen of our demo, we start by selecting the aircraft type, the V-22, for which we see three options. We choose malcodes and further specify top 10 malcodes, and ask the agent to get data by executing that workflow. After fetching and preparing data, an agent paints a visual overview of V-22 malcodes, giving the user multiple different views of top 10 issues. On the left, malcodes by type of issue. On top right, malcodes by operating org. And bottom right, malcodes by owner org. And there are two more panels further down on the right, which we will see later. Let's start with the malcode graph, with MAF counts on the vertical axis for top 10 issues. The view shows typical Pareto behavior with 3 malcodes having majority of records. By clicking on the graph, we bring up the associated NMC hours, showing the 4th malcode generating the 2nd highest number of NMC hours. By scrolling down to the NMC M hours tab and clicking on it, we see individual BUNO records graphed for these types of incidents of broken, burst, ruptured, etc. Some audiences may be interested in specific organizations. Here we group MAF records by organization and highlight the 1st Marine Aviation Wing. By clicking on the graph, we pull up the 86,800 NMC hours for these malcodes at the 1st MAW. This chart displays MAF data by squadron. You'll note that GJ6, with by far the most MAFs, still accounts for less than half the NMC hours at FC3. Continuing our tour, we can delve deeper into the maintenance ecosystem to get an overview of work centers with the most assigned MAFs, or zero in on specific tail numbers. By clicking on either graph, e.g. work center or BUNO, users get details on NMC hours and much more. This concludes our quick demo. While the capability is simple, application of reusable shareable agents is powerful, and with it, we have provided a foundation for future, more complex queries. But to get it right, we need your help. We need to start discussions with maintenance and engineering subject matter experts to understand common needs for our next round of development, which is focused on maintenance optimization and fatigue life management. In this schematic, we show the different kinds of analytics involved. We're asking, depending on job role, where intelligent agents could help you. And for example, where there is opportunity for sharing and reuse among different roles. We are converting the analytics shown in this schematic into a role-based maintenance use case roadmap, starting from the demo you saw today to diving into specialized functions such as evaluating how quickly aircraft fatigue life is being consumed and combining with predictions about component service life to translate into optimized maintenance practices. And separately, we want to work with maintainers to improve situational awareness. We will now show both these in more detail because they are complex and suit intelligent agents perfectly. First, on fatigue life management, we have a 6-step workflow where agents, 1, collect aircraft 1553 sensor data to create a flying history. 2, compare to design specifications from the prime contractor. 3, recognize and assess aircraft flight regimes, thereby 4, supporting fatigue life improvements through calculation of 5, reliability factors, and 6, remaining useful life, leading to optimal maintenance by serial number component. A second use case challenge is providing the right information to maintainers at the right time. If you have heard about head-up displays, you know how they can help speed tasks and ensure accuracy. With devices such as HoloLens delivering information directly to maintainers, we need something like agent technology to manage delivery. In a project known as CELS, a knowledge hub could use agent technology to support use cases ranging from task execution to collaboration across the naval enterprise. In our first work sequence, we'll show how the knowledge hub breaks down a user request between 1, searching for data on a certain V-22, 2, fetching the data, 3, analyzing and running models, 4, presenting results back in HoloLens format. But notice how easily the knowledge hub enables the next step, which is to go from a single maintainer to multiple players, all collaborating with the same data at the same time, and automating updates to critical aircraft records. Indeed, the road ahead by reuse and sharing of assets will quickly evolve into many diverse areas. One of our immediate challenges is organizing the opportunities from the use case roadmap you saw earlier. We intend to prioritize these according to team input on readiness to implement on the horizontal axis and by ability to build based on technical and data capabilities on the vertical axis. By categorizing opportunities accordingly, we will feed our agile development process through completion in March 2023. Thanks for taking a first look at our evolving SAATS project. By circulating this video, we hope to generate dialogue and thinking on these kinds of opportunities. Would you like to be part of a community of interest? Maintenance is teamwork across a community spread far and wide. We welcome any input you may wish to send our way, and thanks for listening.